Welcome PUC secondary students for KCET JEE NEET classes. Let me solve the question number 51. A current 1 milliampere flows through a copper wire. How many electrons will be passed through a given point in each second? As we know, this question is asked in KCET 2019. So here they are asking the how many number of electrons are flowing in 1 milliampere current flows through a copper. So as you know, the solution of this problem, we know that the definition of current is I equals to Q by T. As you know, this Q can be given by what? Number of electrons with what? Charge of the electron divided by time. So by using this mathematical formula, so we can calculate the number of electrons flowing, that is N equals to I into T divided by small e. As you know, the current is given, it is how much? 1 milliampere, that is 1 into 10 the power of minus 3, and that time is asking for each second, means time should we have to take what? 1 second, and divided by, we know that the charge of the electron is 10 raised to minus 19. So here 1 divided by 1.6 into 10 the power of minus 19 comes in numerator. So answer becomes plus 19 minus 3. This is becomes 10 raised to plus 16. So once we solve this one, we are going to get around 6.25 into 10 the power of 15 seconds. So for given 4 option, the answer is option D is the correct answer. Okay, friends, copy the question or you can take the screenshot of this problem. Okay, let's move to next problem, friends. Question number 52. Okay, so in question number 52, the question will be, through the drift electron drift velocity is very small and electron charge is very small, and the conductor can carry appreciably large current because. So in this problem, the electron having the drift velocity and it is very small, and electron charge is also very small. Even though these two are very small, the conductor why it can carry appreciably large current because. Let's solve this problem. So in this problem, we can use the relation between current and drift velocity NEA VD, because as we know, they are talking about drift velocity and charge and current. So this relation through we can get the answer. So here already they have mentioned E stands for charge and VD stands for what? Drift velocity. So these two are very small. But what this N stands? N stands number of electrons. Number of electrons. These are very large in conductors. So this causes, when it is a large number of electrons are present in conductors, this causes what? The current is what? In the large in the metals or conductors. So answer is option B. Option B, where electron number density. So here number of electron also we can call number of electron density, that is per meter cube. per meter cube. So this is the answer for this question, where charge is and drift velocity is very small, even though the presence of number of electrons more, this causes more electrons, more current. So option B is the correct answer for this question. So students, copy these questions for answer. Let's move on to next question. In question number 53, so we have a question number 53. In this question number 53, just read the question. Two cities of 150 kilometer apart. The electric power is sent from one city to another city through a copper wires. The fall of potential per kilometer is how much? 8 volt, and the average resistance per kilometer is 0.5 ohm. Then what is the power loss in the wire? So as you know, so this is problem is based upon the power. Let us, the distance between the two cities is how much? It is 150 kilometer. Let's find out the resistance of the wire. Resistance of the wire, that is R is equals to, is given 0.5 ohm. Let's we find out this 0.5 ohm per kilometer. That should be multiplied with what? Distance of between the two cities, that is 1 kilometer. So here kilometer get cancel. When you multiply 0.5 with 150, you are going to get how much? 75 ohm. Similarly, voltage can be calculated in the same way. 8 volt per kilometer is multiplied what? 150 kilometer distance. Hence, we are going to get how much volt? 120 volt. So as you know, we get R and V. Let's, they're asking power loss. So power loss can be calculated by knowing the datas, that is P equals to V square upon R. So as you know, V is already, it is 120, the power of whole square, and divided by resistance is 75 ohm. Once you calculate, you are going to get how much? 19,200 watt, or we can call, we can make it what? 19.200 kilowatt. As you know, in the given option, which one is correct? Option B is the correct answer for this question. Okay, all dear friends, just copy the answer or do you take the screenshot. Let's move on to next question. In question number 54, in a filament bulb, 500 watt and 100 volt is used for a 230 main supply. When the resistance R is connected in series with the series, it works perfectly. But the bulb consumes how much watt? 500 watt. Then what is the value of that resistance? So this is the that bulb, and it is connected with a resistance, what? Series, and this is that battery. So this is how much volt? 230 volt battery is there, and bulb having the resistance RPM taking, and this is resistance R. First we need to find out what the resistance of the bulb, that is by using the power V square upon P. So here V is given by 100 square, power is how much? It is bulb power is 500. Once you calculate this one, you are going to get how much? 20 ohm. Let's find out current in the bulb, that is I equals to P upon VB. P already they mentioned 500, voltage is 200 volt, so how much you current? 5 ampere. Once you got both resistance and current in the bulb, let us find out. They are asking how much resistance is going to consume by that value of R. That is VR equals to what I'm taking, IR. As you know, the main current is 230 volt minus In that one, we are making the subtracting the bulb voltage, and current is how much ampere, 5, and resistance is calculating. So once you solve this one, you are going to get how much? 26 ohm. So in given option, which one is correct? Option C is the correct answer for this question. Okay, students, copy this question or you take the screenshot of this question. Let's move on to next question, 55. Let's just read the question 55. They given the current equation 20t plus 8t square. Find the charge during the time 0 to t. Minimum is 0 and maximum is 15 seconds. Maximum 15 seconds. Let's calculate this problem. Here, current can be given by what? Charge upon time. As you know, they given the current equation. They are given the current equation. Let us I equals to, what is your formula? dq upon dt. So what is your current equation? 20t plus 8t square. Let's find out dq, and 20t plus 8t square will be integrating with respect to dt with a limit of 0 to dimension 15 seconds. It is 20t plus 8t square with respect to dt. So 20t integration is given by 20t square upon 2, and 8t square is given by 8t cube upon 3. So taking the limits of 0 to 15 seconds, substituting in the above formula. So q equals to 20 into 15 the power of square upon 2 plus 8 into 15 the power of cube upon 3. So after solving these two and adding this quantity with this quantity, you are going to get around 11,250 coulomb. So in given option, option A is the correct answer for this question. Okay. Move on to next question. Question number 56. The flow of electrons is 10 raised to 7 electrons per second in a conducting wire. Current is how much? They are asking the current value. If the flow of electrons is how much? It is given by 10 raised to 7 electrons. So here number of electrons per second is given by how much? 10 raised to 7 electrons. As you know, definition, current is I equals to Q by T. As usual, Q is given by N upon T. So here already N upon T is given. It is how much? 10 raised to 7. And what is the charge here of the electron? 1.6 to 10 raised to minus 19. Once we solve this one, you are going to get how much? 10 raised to minus 12 ampere. So in given option, A is your correct answer. Okay, students, move on to next point. Next question. In question number 57, read which of the following statement is false? As you know, Kirchhoff's second law represents the energy conservation. Yes, of course. In given four option, option A is the correct as a sentence is correct, but they are asking Which one is the false statement? Option B, just read the question. Wheatstone bridge is the most sensitive when all the four resistance are in same order. Yes, this statement is also correct. As you know, in balanced Wheatstone bridge, the cell and galvanometers are exchanged, the null point is disturbed. No. So this is the false statement. As you know, answer C is the correct answer for this question. If you go to the option D, the rheostat can be adjusted for potential divider. Yes, of course, the rheostat can be using for potential divider. And out of four question, option C is the wrong statement. As you know, null point is always remains constant. So it is never disturbed. Okay, students. Move on to next question, students. 58. Okay. So this is asked in 2021. As you know, you can see the circuit. So they're asking the what is the net resistance between this point A and point B. Now in the above given circuit can be resolved into this fashion. And this is the terminal A and this is the terminal what B, and this circuit can be modified into an above circuit as a follow in this fashion. So here by looking at this condition, this is a looks like water which bridge, this is a looks like water Wheatstone bridge. As you know, Wheatstone bridge mathematical formula P by Q equals to R by S, and in the Wheatstone bridge this center part always it is what 0, hence this circuit again modified into what, this circuit is modified into what, as you know the center part is what, galvanometer Iz equals to what, 0 is there. So this circuit becomes as usual in the following circuit it is going to modified. As you know students, these two are what, series, this becomes 2R, again these 2R becomes what, series, again this 2R, again this 2R is parallel to what, 2R above both, because these two are connected across these two ends A and B. Hence once you get the formula of what, RP, we are going to get what, how much answer, 2R upon 2, so final answer becomes what, R. So in given problem answer is what, R. So this 2R is parallel 2R can be resolving by what, using the formula of 1 upon 2R plus 2R, hence you are going to get answer R. Okay students, move on to next question. Question number 59. The resistance of the wire R is ohm. It is melted and stretched n times. Then its original length is new resistance will be how much? So this is problem is based upon the resistivity and of a metal of the wire and length and its area. As you know, the resistivity formula R equals to rho L by A. As you know, from the formula, so one we can take L dash equals to N into L. Okay, and here A into L dash equals to AL. A dash equals to what we are taking, AL. Hence, once L dash equals to AL and L dash equals to NL, by using these two, A dash equals to AL upon L dash, and we know that already L dash is NL, so N L L cancel. Finally, we got A dash equals to A by N. Once you got these two relations, make use of this one. to calculate the new resistance, that is R dash equals to rho L dash upon A dash. As you know rho as it is, what is L dash? L dash is N into L. And what is A dash? A dash is A upon N. Hence, once we solve this one, you are going to get what? N square rho L upon A. Or we can call it what? R dash equals to N square. This rho dash L upon A is what? R is there. Hence, final answer is what? R dash equals to N square upon R. Means the new resistance becomes N square times of the R. So finally 60th question. The question is, which of the following act as a circuit protection for device? As you know, this is a knowledge based question, and the answer for this question is fuse. Fuse itself only what? Act as a protection device. Protection device. Yes, we have solved all the last question number 51 to 60th of this regular CET classes. And thank you students for listening to this class. Thank you.